In this packet tracer file, everything is pre-configured, IP addresses on PCs, on routers, frame relay. On both of these routers, we have the sub-interface, which is serial 000.101. It's a point-to-point frame relay link. So that's as well configured. Routing is configured, so we can, for example, try to ping this router internet from the PCs just to check if everything is working, because our job here will be to block that communication. So we want to make sure that the communication is actually working before we start blocking it. Otherwise, if the communication itself is not working and we start applying these access lists, we might think, oh, the access list was successful because there's no communication, but it might turn out that there was no communication prior to applying that access list. So whenever you want to apply an access list, first check if everything is working as expected. Okay. On to our tasks here. We have 3 tasks. Number 1, ban PC1 from accessing the internet router. This means ban PC1 from communicating with the internet router. When we go to extended access list, you will see that we will be able to ban specific type of communication. So we will be able to ban, for example, only pings, but all other communication will be allowed. So in this case, we are using standard access lists, and in standard access lists, you can only use the source IP as a parameter. So therefore, you're banning the entire communication. Actually, this first access list is quite simple because PC1 has its IP address. So we're just going to ban that one IP address. We're going to use that host keyword. And let me just write here what that access list is going to be. So we're going to say deny host and then list the IP address of PC1, and that IP is 10.0.0.5. And then a very important thing to do is to permit everything else, because if we apply that list to this interface, for example, right here on router internet, and say deny host 10.0.0.5, and then we don't say permit any, the other packets coming from other PCs won't match any other rule. It will directly go to that invisible rule, which is deny any. And then everything will be denied. So no one would be able to access this router. Okay, so that's going to be our entire access list. And where are we going to apply this access list? Well, you could apply it on this interface in the outgoing direction. In case this internet router was a service provider, obviously you can't influence your service provider's configuration, so you would have to configure it here. But in this case, obviously we are the administrators on this router, so we can apply this access list to this interface right here. Now, this interface is not that simple because we have this serial 000 interface, but that's not the interface that has an IP address. That's not the interface that the traffic is going through, at least not the logical interface, right? So we have this sub-interface, serial 000.101. That's the part of this frame relay setup. So we will actually have to apply our access list on that interface, so on that sub-interface. Okay, let's start. Enable configure terminal, and then I'm going to say IP access list standard 1, listing our 2 rules here, deny host, and then we have 10.0.0.5. That's this PC right here. That's the IP address of that PC. Okay. And then I'm going to say permit any. And then I'm going to exit this access list configuration mode, get into that serial interface, serial 000.101 point to point. That's our frame relay interface, which is already configured. It's already existing. It has an IP address. And we just want to say IP access group 1 in. We have already tested that communication without the access list. So let's do it again to see what happens. It's failed. We want to check why that communication has failed. So what's the reason for that? I'm going to go into the simulation mode. I'm going to speed this up a bit and then go forward, forward. And I can see that this packet is going to be forwarded on this router. This is good news because it means that this packet is not dropped for routing, for example. And if it goes through the frame relay cloud, it also means that frame relay is working properly. And we can see this little sign here on our packet. If we open that, we're going to see on the last available layer here that the receiving port has an inbound traffic list with an ID of 1. The device checks the packet against the access list. The packet matches the criteria of the following statement: deny host 10005, the packet is denied and dropped. Notice that this is the in layer, so this is the inbound traffic, right? When we apply an access list to an outgoing or outbound traffic, the packets dropped are going to be displayed here in the outgoing layers. Okay, that's it for access list number 1. Let's move on. Task number 2 says ban all communication between networks 12.0.0.0, that's this network right here, and 14.0.0.0, that's this network right here, in both directions. My advice when you're just starting to think how to approach an access list is to just look at the traffic flow. So you're looking at where would this traffic actually go, right? So when this PC sends something to this PC over, or this one, right? So it's from 12 to 14. So we are sending traffic from PC2 to PC5 or from PC3 to PC5. Either way, that packet is going to get into router 1 on interface fast Ethernet 0/1. So that's incoming traffic for that interface. And then it's outgoing traffic for this interface fast Ethernet 1/1. It's sent to this network right here. Since in standard access lists, we can only block traffic based on the source IP address, the only place where it makes sense to apply this access list is the outgoing interface. So for example, when we are trying to block traffic going from network 12 to network 14, we should apply that list on this interface right here. So we're going to say deny 12.0.0.0 and then wildcard for /24.255. So we want to deny all the packets whose source IP address starts with 12.0.0. And obviously, if those packets are going toward network 14, they're going to be routed on this router and they're going to be sent out this interface because this is where network 14 is connected. Packets going from network 12.0.0 elsewhere are not going to be blocked because then they will be routed to some other place, for example, over here or over here or over here. So that's how we know we are only blocking computers from network 12. Same goes for the opposite direction. For the traffic we want to block that's going from network 14 to network 12, we're going to deny all packets coming from 14.0.0 on this interface right here, fast Ethernet 0/1, in the outgoing direction. So this router is going to get the packets from here. They will be routed to network 12, and then obviously they're going to be sent out this interface because that is where this network is. You will see later on, I might use this same diagram. If we were to use an extended access list, we can say deny packets going from 12 to 14. You could just add network 14 right here. So we could say, let me remove the mask because it's making things more complicated. Okay, so you could just say deny packets going from 12 to 14. And in that case, you could apply that access list here on the inbound direction of this interface, right? So that traffic doesn't have to be routed. It doesn't have to be determined where we should send that traffic. You can just look at this interface and say, if there is someone from network 12 trying to access network 14, we're just going to cut off that traffic right here. But right now we are dealing with standard access lists. So this is how standard access lists work. So let's configure it that way. By the way, I put an enable password on router 1 because our third task is to work with telnet. And in order to be able to access a router via telnet, you have to have an enable password configured. So the enable password is Quince. I put it in this banner, message of the day. So I'm going to say enable, and then I'm going to type in Quince. And then we're going to go to configure terminal, and we can start creating our access list. So we will need one access list for traffic going from 12 to 14, and then we'll need another access list for traffic going from 14 to 12. I'm going to say IP access list standard, and then I'm going to say 2A, because that's the first access list we need for this second task. So this is a named access list. Deny, and let's first start with traffic going from 12 to 14. So I'm going to say 12.0.0/24, which in wildcard is this. And then don't forget the permit any rule. Exit this standard access list configuration mode, and then get into the interface. So we are blocking this traffic on interface fast Ethernet 1/1. We're going to say IP access group 2A out. Once more, what's going to happen on that interface? Oh, look at that. I picked the wrong interface. Luckily, the command to remove this access list is simple. I'm just going to remove the access list from this interface, open the correct interface, which is fast Ethernet 1/1, and then say IP access group 2A out. Okay. Once more, what this access list will do is this interface is now going to look at all the traffic that's coming out of this router through this interface towards the local area network of 14.0.0.0. And if there are packets with source IP 12.0.0 something, those packets are going to be dropped. All other packets are going to be permitted. All right, we are supposed to create our second access list on the same router. So let's do it right now. IP access list standard to B. I'm going to say deny 14.0.0.0 wildcard /24/00020 255 and then permit any. Exit interface fast Ethernet 0/1. This time I'm using the correct interface. And we're going to say IP access group to be out. Let's now test that. Sending a packet from PC2 to PC5. It failed. Let's look at the reason. So the packet arrives to router 1, and then we see this error here. As I already mentioned, in the inbound layers, we don't see anything strange. The device looks up the destination IP address in the routing table. The routing table finds a routing entry. The destination network is directly connected, blah, blah, blah. The outgoing port has an outbound traffic access list with an ID of 2A. The device checks the packet against the access list. The packet matches the criteria of the following statement. deny 12.0.0.0.0.0.255. The packet is denied and dropped. By the way, if you want to look at what happens when you send a packet that also matches the access list, but it matches this permit any rule, I'm going to try to send a packet from PC1 to PC5, and that's successful. And let's look at how that looks like. So on the inbound interface, the device looks up the destination IP, blah, blah, blah. The outgoing port has an outbound traffic access list with an ID of 2A. The device checks the packet against the access list. The packet matches the criteria of the following statement: permit any. The packet is permitted. You can see here that all packets have to be compared to all of the rules inside of an access list. Okay, so all of the rules before the rule that is matched, right? Okay, that's it for the second task. Let's move on to our third task. Ban PC2 from accessing router 1 via telnet. Okay, first of all, I'm going to test telnet access. You access a device via telnet by opening the command line prompt, or whatever it's called. Yeah, command prompt. Okay, and we're gonna say telnet and then use one of the IP addresses of router 1. We can use 12.0.0.1, for example. And we can see that we are now here. If we type in enable, it's going to ask us the password. We're going to type in quince, and we are in router 1. So configure terminal, right? We're in configuration mode. We can change something, whatever. I'm going to exit telnet and try it from a different router, PC1, because we will not be blocking PC1 from accessing via telnet. I'm going to say telnet 12.0.0.1. It works. Enable, quince, show run, for example. Okay, I'm going to exit out of this one as well, and then move on to our access list. First of all, I don't think we've mentioned telnet in this course so far, but I might do an exercise only with telnet, so to kind of figure out how to use telnet, especially in Cisco Packet Tracer. It's a bit different than in real life, but you actually shouldn't even be using telnet because it's not secure enough. So yeah, anyway, it's heavily used still. The routers, actually, the Cisco routers, have sort of an interface for telnet. It's called a line. And on this router in particular, there are 16 parallel lines. So these are the number of connections you can have at the same time via telnet. To open that interface, you say line VTY, and that stands for virtual teletype. And then since there are 16 different lines, as you can see here, if you want to have an access list where you are limiting someone from accessing via telnet, you want to cover all the different lines so that that person can't just use a different line which doesn't have an access list on it to access via telnet. So I'm just going to say 0 to 15. And like this, I have covered all of the 16 lines. This is where we will be applying our access list, just as if it was a physical interface such as serial or fast Ethernet, so it doesn't really matter. But we will use that later. We need to create the access list first. The access list is actually going to be fairly simple because all we are requested to do is ban one PC from accessing this router via telnet. So it's going to be IP access list standard 3. And then we're going to block that one host IP. That's PC2. That's 12.0.0.5. And then don't forget to type in permit any, because we do want other PCs to be able to access this router via telnet. We are only blocking this one IP address. All right, then align virtual teletype 0 to 15. And then the command is a bit different here. It's access class, and then you say 3, and then you say in. That's pretty much it. You have all of the access lists and all of the interfaces to which they are applied here in this exercise guide. So this is pretty much it. We want to test this right now. So PC2 command prompt telnet 12.0.0.1, and it says connection refused by remote host. Let's try it from PC1 to see if it's still working for everyone else. Yep, we're in. Well, that's it for our exercise. See you in the next one.